This video provides easy-to-follow instructions for you to create this valve body using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 5 segments. In segment 1, you will read the engineering drawings. Segment 2 will establish the design intent. In segment 3, you will create the part model using Onshape. Next, you will check the accuracy of your model by checking its mass properties. Last, you will check the design intent by making changes to the model to see if it will update correctly. Now you are ready to begin the project. In this segment, we'll review the engineering drawings for this valve body. We will start by identifying the views. First, there is an isometric drawing to help us visualize the part in 3 dimensions. Next, the orthographic views show the 3 primary views as flat 2D drawings. In third-angle projection, the front view is in the lower left. Projected above the front view is the top view. Projected to the right of the front view is the right side view, shown here as a half section. The hatched areas show where the material was cut to reveal the interior features. The cutting plane line in the front view shows us the location and view direction of the section view. In planning our parametric model, it is important to identify the basic shapes and features of the part. The top view shows the shape as a cylinder with a uniform diameter and consistent wall thickness. Around the edge of the top and bottom are evenly spaced mounting tabs with bolt holes. There is a circular boss extending from the front of the cylinder. There is a smaller circular boss extending from the back of the cylinder. Concentric to the front boss is a counter bore hole. Concentric to this counter bore is a blind hole that extends to the back boss. Evenly spaced around the boss are 3 threaded holes for mounting a retainer plate. Next, we can read the dimensions and notes. First, the measurement units are in millimeters. The top view shows the inside diameter of the valve body at 200 millimeters. The outside diameter is 250 millimeters. This results in a wall thickness of 25 millimeters. The body has an overall height of 250 millimeters. The 3 top and bottom mounting tabs are evenly spaced around the center of the circular body. The centers of the bolt holes are coincident to a center line circle with a diameter of 320 millimeters. This makes each hole center 160 millimeters from the cylindrical center. Each mounting tab has a through hole with a diameter of 25 millimeters. The semicircular end has a 30 millimeter radius and it's concentric to the hole. The front view shows the bracket thickness of 15 millimeters. A flat circular shaft mounting boss is located on the front of the cylinder and has a diameter of 175 millimeters. This boss extends 25 millimeters from the front of the cylinder. Opposite is a smaller boss with a receiving hole for the shaft, with a diameter of 100 millimeters. This boss extends 25 millimeters from the back of the cylinder. Concentric to the front boss is a counter bore hole with a diameter of 100 millimeters. This has a depth of 25 millimeters. Concentric to that is a shaft hole with a diameter of 60 millimeters. This hole has an overall length of 260 millimeters, ending in a blind hole in the boss on the opposite side. Concentric to the shaft hole, there are 3 retainer plate screw holes. They are located on a centerline circle with a diameter of 137.5 millimeters. This makes the distance from the center of the boss 68.75 millimeters. They are evenly spaced at 120 degrees. The hole callout tells us that these holes are 10.3 millimeters in diameter and drilled to a depth of 35 millimeters. The holes are threaded with an M12 by 1.75 tap to a depth of 29.75 millimeters. The material for the part is aluminum 6061. Before we model the part in Onshape, let's review the design intent. For this project, we intend our model to be flexible to possible design changes so it will behave predictably if revised. To start, we need to identify any features that might be changed during the design process. First, the inside diameter of the valve body may need to be changed either larger or smaller. This will cause the outside diameter to also change. Also, the overall height of the valve body might need to be increased. Next, let's identify the features that should remain unchanged after a revision. The wall thickness should remain unchanged. The part should maintain its symmetry top to bottom, with the boss and shaft mounting holes centered on the cylinder. All other features and their locations will remain unchanged. So how do we want the part to behave when it is changed? We should be able to change the inside diameter and the overall height, and the other features will update without errors. In this segment, we will model the valve body using Onshape. Let's start by previewing the features we will use to create this parametric model. First, we will choose the top view for our base sketch and place sketch 1 on the top sketch plane. The center of sketch 1 will be coincident to the origin on the sketch plane. With extrude 1, we will create the cylinder. In sketch 2, we will define the size of the bosses and holes. With extrude 2, we will create the rear boss. In extrude 3, we will create the front boss. With extrude 4, we will create the shaft hole. In extrude 5, we will create the counter bore for the shaft hole. Extrude 6 creates the vertical hole through the center. Sketch 3 defines the size and location of one mounting tab. Extrude 7 creates the mounting tab. Circular pattern 1 adds evenly spaced tabs on the top. Mirror 1 adds the tabs to the bottom edge. Hole 1 adds one instance of the screw holes to the boss. Lastly, circular pattern 2 adds the remaining screw holes to the boss. Now let's get started creating this part using Onshape. I've started a new Onshape document and named it Valve Body. Before starting the sketch, I want to check my workspace units. Make sure the length is set to millimeters and the mass is set to kilograms. As stated in the design intent, we have identified 2 parameters that we may need to change during the design process. We will start by creating variables for these parameters. Click on the button on the right to open the variable table for the document. The first variable is the inside diameter. Use ID as its name. This is a length. It has an initial value of 200 millimeters. The other is the vertical height. Use height as its name. It is also a length. It has an initial value of 250 millimeters. Click the button to close the table. Notice that these variables have been added to the top of the feature list. Now I'll start a new sketch in this part studio. Click on the top sketch plane. Use N on the keyboard to view normal and P to turn off the visibility of the sketch planes. We will use the sketch to establish some basic features of the part, including the inside diameter, the wall thickness, and the distance of the bosses to the outside of the cylinder. From the toolbar, choose Center Point Circle. Click coincident to the origin to start the circle, drag and click. Click coincident to the origin again and create another larger circle. These circles represent the outside of the cylinder and the center hole. We will start by setting the wall thickness. Click on the dimension tool and click on both circles. Set the distance to 25 millimeters. Now we can set the inside diameter. Click on the inner circle. Use hashtag to open the variables and choose ID from the list. Use Enter to display the value. It should be 200 millimeters. We will now use construction lines to set the distance from the outside of the cylinder to the faces of the front and rear bosses. Click on Line and then Construction. Hover the mouse at the origin and move down to the outside of the circle. Look for a vertical and coincident icons and click to start the line. Extend the line down vertical and double-click to end. Set the length at 25 millimeters. The end point of this line is the location of the face of the front boss. Use the same process to create a lineup on the top for the face of the rear boss. From the Constraint menu, click on Equal to set both lines equal. This looks correct. Use the green check to close. Right-click and view isometric. We can now use Sketch 1 to create the base cylinder. From the Feature toolbar, click on the Extrude tool. This will be new. Click on both regions of the inner and outer circles to form a solid cylinder. We will remove material from the center later, after creating the bosses. The end type will be blind. Click on Symmetric to extrude in both direction from the sketch plane and leave the origin at the center. Set the depth using a hashtag and choosing height from the variable list. Use Enter to display 250 millimeters. This looks correct. Click the green check to accept and create the base part. To sketch the circles for the bosses, we will need a new sketch plane. First, click on Part 1 in the Parts list and turn off its visibility. Next, in the Feature list, click on Sketch 1 and turn on its visibility. Now click on the Plane tool on the toolbar. This will be a plane point. Click on the end point of the construction line in the front. This will be the point to place the plane. Use P on the keyboard to turn on the visibility of the planes. Click on the front plane and a new parallel plane is created at the point. This looks right. Use the green check to close. Notice plane 1 has been added to the feature list. Referring back to the drawing, there are 3 elements that define the features on the bosses: a 60 mm center hole, a 100 mm countersink and back boss, and a 175 mm front boss. In the parts list, click the part and turn its visibility back on. Start a new sketch and click on plane 1 for the sketch plane. Use N on the keyboard to view normal. Using the origin for the center, use the center point circle to construct the elements: a 60 mm diameter circle, a 100 mm diameter circle, a 175 mm diameter circle. That looks good. Use the green check to end the sketch. Right-click and choose Isometric View. The first feature we will add here is the rear boss. Click on the Extrude tool on the toolbar. Use Add. For the sketch region, click on both of the center circles. For the direction, toward the rear of the cylinder. For the end type, choose up to vertex. Click on Sketch 1 on the feature list to turn on its visibility. Click on the endpoint of the rear construction line to use it as the vertex. This looks correct. Use the green check to close. We can now remove material for the shaft hole. Click on Extrude again. Use Remove. Click on Sketch 2 to turn on its visibility. For the region, click on the center hole. Direction is toward the rear. End type is up to face. Click on the face of the rear boss. We don't want the hole to go all the way through, so we will use an offset for the hole to stop. Looking back at the drawing, the hole ends leaving 15 mm of material at the rear boss. Enter 15 mm for the offset. Use the green check to close. To check on the depth of the hole, we can use a section view. Click on the camera and render options and choose section view from the menu. Click on the right plane to use as the cutting plane. Use the green check to close. The hole should be visible. Click on the measure tool in the lower right. Click on the face of the rear boss. Click on the end face of the hole. The measurement should be 15 mm. This looks right. Right-click and turn off section view. We can now add the front boss. Click on Extrude. Use Add. Click on Sketch 2 and turn on its visibility. For the region, click on the outer region of the sketch. The direction is toward the cylinder. The end type is up to next. The boss should extend to meet the cylinder. This looked good. Use the green check. The last step for the boss is adding the counter bore hole. Click on Extrude. Use Remove. Click on Sketch 2 again to view. Click on the center region for the counter bore. The depth is 25 mm. This looks correct. Use the green check. With the bosses done, we can now remove material to form the center hole. Click on the Extrude tool. Use Remove. Click on Sketch 1 to make it visible. If needed, turn off Part 1 in the parts list to view the sketch. Click on the center region of the sketch. The end type is through all. Click the box for symmetric to both directions. Turn back on the visibility of Part 1 to view the result. Click on the Merge scope and click on Part 1 in the parts list. This looks correct. Use the green check to close. Next, we will use a sketch to define one of the mounting tabs on the top outside edge. Referring to the drawings, the center of the mounting hole is 60 mm from the inside edge of the cylinder. The semicircular end of the tab has a radius of 30 mm or a diameter of 60 mm. The bolt hole is concentric to the semicircular end with a diameter of 25 millimeters. Start a new sketch and click on the top face of the cylinder for the sketch plane. Use N on the keyboard to view normal. Click on Line and Construction. Hover at the origin and move up to the inner edge of the cylinder. When you see the vertical and coincident icons, click to start and stretch a vertical line. Double-click to end. Enter 60 millimeters for the length. Click on the slot tool on the toolbar. Click on the construction line. Double-click on the diameter and enter 60 millimeters. Click the left mouse button to end the slot. For the bolt hole, click on the center point circle tool. Click coincident to the end of the construction line. Enter 25 millimeters for the diameter. This looks correct. Use the green check to close. We can now extrude the sketch to create the tab. Click on the Extrude tool on the toolbar. This will add to the existing part. Click on the portion of the sketch for the tab. This should extrude down toward the body. The depth is 15 millimeters. This looks good. Use the green check to close. Next, we can create the 2 additional incidences of the tabs on the top edge. Click on the Circular Pattern tool on the toolbar. Choose Feature Pattern from the drop-down menu. For the feature to pattern, click on the Extrude for the tab. For the axis of the pattern, click on the center hole of the part. For the instance count, enter 3. Check the box to reapply features. This looks right. Use the green check to close. The same pattern of tabs are also on the bottom of the part. We can mirror the set to create them again on the bottom. Click on the Mirror tool on the toolbar. This will be a feature mirror. For the features to mirror, choose the Extrude for the tab and the Circular Pattern from the feature list. To choose the mirror plane, use P on the keyboard to turn on the visibility of the planes. Click on the top plane. Check the box to reapply features. This looks like what I wanted. Use the green check to close. Next, we have the 3 threaded holes on the face of the front boss. The centers of the holes are located on a centerline circle with a diameter of 137.5 millimeters. This makes the distance from the center of the boss to the hole center 68.75 millimeters. To locate the hole, we could use a sketch or a mate connector. Let's use a mate connector. I need to use the tool to add a mate connector, but I don't know where it is on the toolbar. Click on the Search toolbox and enter mate. I can click it here on the list. I want to choose a mate connector on the front of the boss. Click on Front on the View cube to view this face. I only see one mate connector at the center. I will choose this one and then check Move in the dialog box. I want to move the location vertical in the Y direction, 68.75 millimeters. This looks correct. Use the green check to close. Notice this mate connector has been added to the feature list. Now we can add one instance of the hole feature on the boss. From the drawing, we can see it is a metric threaded hole for M12 bolt with a 1.75 thread pitch. Click on the Hole Feature tool on the toolbar. This is metric. This is simple. It is tapped. It is M12. It has a pitch of 1.75 millimeters. The drill diameter is 10.3 millimeters. The hole is drilled to a depth of 35 millimeters. I have set the drill size to 10.3 millimeters. The depth to 35 millimeters. Last, the hole is threaded to a depth of 29.75. And that is set here. For the hole option, click on the button for the mate connector in the dialog box. Click on the mate connector on the boss. That looks good. Use the green check to close. We need 2 more screw holes for the set. We can use a circular pattern feature to add them. Click on Circular Pattern on the toolbar. From the drop-down, choose Feature Pattern. For the feature, click on the hole. For the axis of the pattern, click on the center hole. For the instance count, enter 3. This looks right. Use the green check to close. With this, our valve body is complete. In this segment, we'll check the accuracy of the model by checking its mass properties. To check the model, the mass unit should be set to kilograms and the material set to aluminum 6061. If the size and shape of your model was completed accurately, the mass should be 14.499 kilograms. Let's review this process step by step. First, open the document that contains the model of the valve body. Next, check the workspace units and make sure that mass was set to kilograms. Next, we will set the material to aluminum 6061. Go to the part in the parts list. Right-click and click on Assign Material. In this case, we're searching for aluminum 6061 with a density of 2.720. Click to select it. Next, go down to the lower right corner and click on the Display Mass Properties button. When the dialog box opens, click on the part, and the display shows a mass of 14.499 kilograms. If this was your result, then your part is accurate and matches the specifications. If the mass of your part does not match, let's troubleshoot each feature to look for an error. First, locate the rollback bar in the feature list. Move the rollback bar up so that only the Extrude 1 feature is displayed. The mass reads 33.379 kilograms. If this is not your result, look for an error in Sketch 1 or Extrude 1. When your value is correct, move the rollback bar down the feature list to the other side of Extrude 2. The mass is now 34.557 kilograms. If your mass doesn't match this amount, look for an error in Sketch 2 or Extrude 2. Move the rollback bar to include Extrude 3. The mass is now 32.365 kilograms. If your mass doesn't match this amount, look for an error in Sketch 2 or Extrude 3. Move the rollback bar to include Circular Extrude 4. The mass is now 33.95 kilograms. If your mass doesn't match this amount, look for an error in Sketch 2 or Extrude 4. Move the rollback bar to include Extrude 5. The mass is now 33.608 kilograms. If your mass doesn't match this amount, look for an error in Sketch 2 or Extrude 5. Move the rollback bar to include Extrude 6. The mass is now 13.765 kilograms. If your mass doesn't match this amount, look for an error in TH Sketch 1 or Extrude 6. Move the rollback bar to include Mirror 1. The mass is now 14.523 kilograms. If your mass doesn't match this amount, look for an error in creating and duplicating the bolt tabs on the top or bottom. Last, move the rollback bar to the end. The mass is now 14.499 kilograms. If your mass doesn't match this amount, look for an error in creating and duplicating the screw holes. If your amount now matches, congratulations, your part is completed accurately to match the drawing. In this segment, we will make some revisions to the design and check if our design intent has been applied correctly. We will start by reading the revision drawings to identify the features that will be changed. The top view shows that the inside diameter of the valve body is now 250 millimeters. The front view shows the height has changed to 300 millimeters. All of the other features should remain unchanged. The material remains aluminum 6061, and the revised mass is now 19.997 kilograms. Now we will make the revisions to the part. As stated in our design intent, we anticipated that the design would be revised for the inside diameter and the height. We set variables for these parameters so they can easily be changed. We also set other constraints so that the change would not conflict or make unwanted changes to other features. For example, in Sketch 1, we set the dimensional parameters so that the inside diameter could change, and the wall thickness would not change, and the distance to the outside faces of the bosses would not change. In Extrude 1, the height was set symmetric to the origin so the height could change, and features constrained to the origin would stay in the same relative location. I have opened my Onshape document of the valve body. On the right, click on the button to open the variable table. We can change the values here, and the model will automatically update. Let's start by changing the inside diameter to 250 millimeters. I can see this updated without errors. Now change the height to 300 millimeters. Again, this looks good. Last, let's check the mass properties of the revised part. Its mass is 19.997 kilograms. This is accurate. Congratulations on completing this project. Thank you for watching. If you enjoyed this video, look for more projects at cadvideotutor.com. Also, hit the like or subscribe button. If you have a question, leave a comment.